So we're going to end week 4 by talking about force development. Now, I want to make it clear that force development and force production are different, but they go hand in hand. And so with force development, we're going to talk about 2 things today. We're going to talk about a couple of different conditions that we're going to define, and then we're going to talk about how force production is different between twitch, summation, and tetanus. So the first thing is, why is force development so important? And the easy answer is not everything is equal, right? Not all tasks are equal, all right? Picking up a baby requires much different force than picking up, a 200-pound box or something. That sounds really heavy, but you get my idea, okay? It requires more force to throw a ball 50 yards than it does to throw it 5 yards, okay? It also requires more force to throw a ball over those mountains like you could. So you should have won state if you're Uncle Rigo trying to win in Preston, Idaho, the state football championship in like 1983. Highly underrated movie. All right, so remember, individual motor units generate force, and they generate it maximally. The thing is, individual motor units can generate different levels of force. What? Okay, you've got the all or none principle, right? The all or none principle says that, the all or none principle says that when a motor unit fires, it fires maximally. That's absolutely true, but we probably ought to add a little bit more to it. And what we should say is that when a motor unit fires, it fires maximally for the condition that it is in. Okay, and so we can change this a variety of ways, and one of those is by frequency. Okay, if we just have a small individual twitch where the muscle contracts and then it relaxes, like this first little bump on the this figure here, we call that a twitch. Okay, so contracts, relaxes, nothing else happens. Okay, but if we have a second stimulus or a second contraction that occurs before the muscle is fully contracted, then we call that a summation. And notice what happens is we've got greater force production. Okay, so now we're here. Now, if we stimulate the muscle often enough or at a high enough frequency, what will end up happening is that we experience something called tetanus. Okay, so if a muscle or a motor unit's constantly stimulated, tetanus occurs, and it's a weird thing. We don't have the equipment here, but at Oregon we did, where we could just put like a bar electrode on the radial nerve, and it would cause tetanus. We could experience tetanus in our thumb, and so our thumb would contract. You'd have, I guess that would be thumb flexion. And it felt really weird, which was fine, didn't hurt, but you couldn't extend your thumb because it was the flexors were being stimulated so rapidly that the muscle couldn't relax. And so we generate maximal force. We have greatest force production during tetanus. Muscle's not given a chance to relax. We're getting as many cross bridges as we possibly can. And so we have great force, great tension, great contraction. And so that's how we're ending week 4.